Don't bump that, Brendan.
Okay. So, last week.
You want our test bag?
Yes, I got it.
I want to keep it. I knew you want our test bag. So I can look at what mistakes I made.
Okay. Here we go. We are in our notes. And we are ready. We're on the back of page 19, and we're ready for letter B, which is x minus 2 over 1 minus x. Now, guys, gotta get busy. We have a lot to learn here. So, we're graphing these things called rational functions. And our responsibility is to put all of the asymptotes and intercepts into the picture. Then we know that this is a version of the reciprocal function. So I'm going to have that shape just with some moves and switches around a little bit. All right, who remembers from the one we did Friday where we find or how we find vertical asymptotes? What makes the denominator 0? So you simply look up here, and usually you can tell just by looking, but if you wanted to actually set it equal to 0 and solve it, you can. But usually you can look at it and see, well, if I put a 1 in there, I get a 0, right? And that's where vertical asymptotes come from. What makes the denominator 0? So my vertical asymptote is at 1. So it's a vertical asymptote, x equals 1. If I have not already made a note, I would make a note in my notes that vertical asymptotes are when the denominator equals 0. All right, now who remembers the horizontal? Where does the horizontal come from? You look at just the x part of the problem. So this one's a little whopper-jawed because of the order. But if you put x over negative x, what does that reduce to? Negative 1. So your horizontal asymptote is at negative 1. We box in the x's and look just at the x's. Now, this problem has no holes. We hope to get to one that has holes later today, but in order to have holes, you have to be able to factor and cancel in your problem. Nothing factors and cancels here, so there aren't going to be any holes. You must factor and cancel to get a hole. The intercepts are points, and they're points that are found by letting each letter be 0 one at a time. So in other words, I'm going to let x be 0, and I'm going to let y be 0. Be careful. Oh, never mind, they're not written down. All right, so if I put in 0 for x, go back up to the original problem. If I put in 0 for x, I have negative 2 over 1, don't I? So my y-intercept is 0, negative 2. To find the y-intercept, we do what we always do. We let x be 0. I just put in 0 for the x's and figure out what that is. Now, to get my x-intercept, I let y be 0. So that, if I let y be 0, it's going to look like this.
Wait, couldn't it be 2?
To solve that, I'm going to multiply by the denominator, get it over here, but it's going to stay 0, because multiplied by anything gives me 0. So this looks like x is going to equal 2. So my x-intercept is at 2, 0. It will always happen that your x-intercept comes from the numerator, because the denominator will always disappear because of the 0 thing. Okay? Now, I need to draw the picture. Remember, it has to be some version of this, but it has to contain those points. So see this point right here? That means I must have a piece of the graph down here like that. And what does this point mean? I must have a piece of it up here like this. And there it is. Now, the next one looks a little bit bigger. Tell me what you think about this. You gotta start. What'd you say? Well, there's squares in there. I'm not going to square root it, but I can factor it. I can factor it. And factoring is the first step to getting some holes. So I'm going to factor it, and if anything cancels, we will have our first hole. But I don't think anything's going to cancel, is it?
No.
Okay, so there's still no holes. Now, what about vertical asymptotes, guys? Looks like there are going to be two of them, because vertical asymptotes happen when the denominator equals 0, and aren't there two different numbers that would make a 0 down there? So you're going to have a vertical asymptote at 3 and another one at -3. Now for your horizontal asymptote, I think it's easier to look at the original problem. What's your horizontal asymptote going to be? 1? Because it's x squared over x squared. Now if you put 0 in for x, you can do it here or here. It doesn't matter. I like to put it in here, because if I put 0 in for x, real simply, I can see I'm going to get what? What am I going to get if I put zeros in here? What's 0 minus 4? What's 0 minus 9? So don't I get -4 over -9? Or 4/9? You will get the same thing if you put it in here. It's just a little more work, because there's more places to put it in. Now I'm going to let y be 0. So I'm going to go back to my original problem, go back to my problem here. And if I put in a y, 0. Oh, I should be writing it here, but I put in 0 for my y. Now what's going to happen to the denominator? It's going to disappear, because you're going to bring it over here and multiply it. But since it's 0, it's just going to be gone. So what makes the top 0 then? What makes this 0? Either 2 or -2. So not only do I have 2 vertical asymptotes, but I have 2 x-intercepts. I have one here, and I have one here. And what was my y-intercept? Having that extra asymptote really kind of messes up our picture. Any idea about any part of that picture? Do you see anything happening there? Can you kind of see a parabola here? Remember, as you draw, you're gonna get closer to your asymptote. Any idea what's going on out here on the ends?
Nothing.
Oh no, there's something there. You're always gonna have part of your, there's, the whole graph's gonna be filled in. Well, over here, you're going to have this. And over here, you're going to have this. Now, those are the reciprocal function pieces, these things. And your question is probably, well, Mrs. Ford, how did you know to draw them there? Well, there's a reason for me having you do this. Because as soon as you tell me that these are the intercepts, that means those are the only places where we cross an axis. The reason that we put the asymptotes in is because the curve, as you draw it, will always approach its asymptotes. So I want you to think about over here, I have to approach my asymptote. But I can't cross the axis. Think about that. What would happen if you drew it down here like this? That would be a possibility, but what would happen? Yeah, not allowed. So my only option is this. Similarly, same argument over here. I could draw this in, but I'd cross the axis, and these are the only places you're allowed to cross. So it has to look like that. As you go off the page, kids, make sure that you are getting closer to an asymptote. As you go off the page, you're getting closer to an asymptote, no matter which way you're going. Miss McCarthy, can I help you?
I'm just gonna get something back there.
Oh, you can, sure. No, feel free, that's fine. All right, so that one was kind of weird. Let's try the next one. Oh, we're not going today.
Oh, okay.
We have too much to do.
That's fine.
We'll go after this next problem.
Cute.
You guys just had a surprise long flex, so you don't need
How long
to.
was it?
30 minutes. It's a short class.
Okay, here we go. This is a big one. Let's look it over. Let's look it over and see what we can do with it. What do you notice when you look at the problem?
It's factorable.
It's factorable. Now, some of you might, right from the beginning, look at this part and say, oh, I know my horizontal asymptote will be 1/2. 1x squared over 2x squared. Remember, we always look at the highest power.
Yeah.
So you can do that right off the bat. You can do that right off the bat. Now, I'm with you though. I want to get this thing factored. So how does the top factor?
X minus 5 times x plus 1.
Yeah.
Is that all right with everybody?
Yeah.
Now, on the bottom, you can take out a 2 and then factor the rest of it into x minus 2x plus 2. Shoot, I was thinking something might cancel,
Wait, is there a
but
hole? No.
nothing did, because the only way you can have a hole is if something here matches and you can cancel. Nothing matches. So this is going to be another strange picture. Because once again, aren't there 2 vertical asymptotes?
Yeah.
Okay, so that causes strange things to happen. So my vertical asymptotes are at 2 and -2, and my horizontal asymptote is at y equals 1/2. else do I need? Y-intercepts. Yep, y-index intercepts. Okay, so remember when we do intercepts, that you can always tell if you graph the point which one it is, but in general, it's the opposite letter that's 0. So if you're looking for a y-intercept, you're going to let x be 0. But never be confused. If you just plot your points, you can tell which one it is. It'll be on either the x-axis or the y-axis. Well, let's put zeros in, and you can put them in wherever you want. I like to go back to the original. What happens if I put a 0 here and here?
-5 or
Negative
5/8.
5. And what happens if I put a 0 here?
-8.
-8. So my y-intercept is at 5/8. Now, this is really important. Remember, you have an asymptote at 1/2. That's 4/8. So your intercept is actually going to be a little bit above that asymptote, right? Because it's at 5/8 and 1/2 is 4/8. So this is 0.5/8. Now, x-intercept, I'm going to put 0 in for y. And do not be afraid. This is an easy equation to solve. It's super easy. Because what happens to the denominator? It's gone. So basically, aren't you solving this right here? So x is either going to be -1 or +5. So my x-intercepts are -1 or +5. Now I'd like you to look at, this is a very strange picture, but I need you to think about the fact that, look over here, you can't cross the axis over here. So doesn't it have to look like this?
Yep.
Because you can't cross the axis. Now on this side, I do cross right here. So doesn't this one look like this?
Yep.
But what's happening in the middle is extremely strange. You cannot cross anywhere but here and here. And as you go off the page, you have to approach your asymptote. So I'm thinking, guys, I've got like a tangent shape in there. You did not know it could be this exciting, did you?
It's getting crazy.
It is crazy.
It's a tangent.
Now, that middle section is always the wild card. The last one we did, our middle section had a parabola.
Right.
And that's okay. But if you tried to draw a parabola here, do you see what would happen? And it can't do that. It can't cross. So if it can't cross, it's got to go up. Would you agree with me? And that's it. All right, so now we're going to go to lunch. Now we have short lunch today because we have a short period. So I need you back at 55. Yep, 55.